Alrighty, so this final sort of concept I'd like to go over is some basics of Linux networking. Now this will 100% not be all encompassing, but it will be a sort of primer to this. The first thing we can look at our IP address, or you can shorten that to IPA, and we can see all of our interfaces. Now what do these mean? Here we have LO, which is our loopback interface, which is just an interface a computer will use when it wants to contact itself. This ENP0S25 is the Ethernet port. This WLP3S0 is the wireless card, and this TUN0 is a tunnel or a VPN connection. Now, there's sort of a formula that will tell you what each type of interface is. There's some stuff you have to just know, like TUN0 is going to be your VPN connection, and the more VPN connections you have, it will just increment that 0. So if you have 4 VPNs open, you'll get 0, 1, 2, and 3 for your TUN interfaces. And again, loopback, that's going to be common on everything, so that's another thing you just have to know. But for my interfaces 2 and 3 here, we see ENP0S25. That's broken down into EN, which is the type of device. We can see EN for Ethernet. We can see WL for a wireless LAN. And we can see WW for a wireless WAN. Now EN and WL are by far the most common out of the three because most laptops don't have a wireless WAN port. Now the next sort of pieces of information are the P and the S. We can see there are different types of ways you can connect these devices to a computer. And if it's on board, it will have an O. If it's a hot plug slot, it will have an S. And if it's a PCI location, and if that naming scheme fails for one reason or another, it will fall back and you'll commonly see something like ETH0 or ENS and then a number. So in general, to reiterate, L is gonna, like an LO will typically be a loopback, and N or ETH will typically be an Ethernet port. A WL or a WLAN is going to be a wireless card, and then a TUN will be a VPN connection. So this IP command here is sort of what you use for the most part when it comes to configuring networks on Linux. So it's helpful to know some sort of shortcuts when it comes to this. So IPA, you can shorten address down to A, and then you can show, or it might be device TUN0. Yeah, it's show, my bad. Show TUN0, and that will isolate one device. So say I just want my wireless card, because that's the one with an actual IP address on it. I can isolate that with IP address show and then WLP3S0. And here I can see my IP address 192.168.1.123. And the next sort of important command is IP route. And here we can see sort of all of the routes on the on this device. We can see our default route is 192.168.1.1, so that's going to be my default gateway. And then we have the route for the VPN traffic, and you can tell that because it's going to a 44 network on this VPN tunnel. And here we can see this is just a connected network. Here again we can see I can access a 172 network from this VPN tunnel. And finally, this is the locally connected wireless LAN with the 192.168.10/24. So that's sort of some of the. So these are the routes and how your Linux server will transmit traffic. So that is how you can look at your routes. But if you'd like to add a new one, all you have to do is IP route add the network you'd like to go to in CIDR notation, and then you can set a default gateway if you'd like. Let's go 15, and then you set your device you'd like to connect with. I'll just go with my wireless card, and you do need sudo permissions to do that, and you can see that that route was added to the table. Now that network doesn't exist, I just did that as an example to show you how to add routes. Next really important concept is how to more easily edit your network information. Now my favorite utility is NMTY, and here we can go into edit a connection. For example, let's edit here. We could change a lot of stuff about here. You could change this from automatic to setting yourself a manual address and doing all of that here. And if you remember just how sort of complicated that was without in the how to set a route, you'll realize how useful this Network Manager TUI really is. And this is installed with the Network Manager package. So if you install that, you should have this NMTUI, and I think it's fairly intuitive on how to use it. So that's one way you can easily change your network information. Alrighty, so the next sort of important concept is some important network information sort of files. The first I'll talk about here is etc hosts, and if you look here, you can manually define DNS entries, which is good if you have local entries. If you just want to manually define some stuff, you do it in the etc hosts. Pretty simple. IP address and then the host name. And then for to continue on the theme of DNS, the resolve.conf file. Now in my instance it's generated by Network Manager, but you can manually enter your name server and then whatever you'd like it to be. There are some pretty famous ones: 1.1.1.1, 8.8.8.8, and 8.8.4.4. One thing I will say is within ASN 17, I believe, is Purdue's autonomous system, you cannot access 8.8.8.8. So as long as you're on campus, you shouldn't be using that as your DNS server or trying to ping it for network connectivity. Just as a little side tangent. Another file, etc hostname, which is the host name of your system. You could edit that and change sort of what it is. And for those three files, your etc hosts, etc resolve.conf, and etc hostname are just three examples of important files where you'll find networking information. The next sort of important concept to talk about is what are your active connections? And you can do that with ss-tulpn. And this will show you all of your active network connections. And as you can see, all of mine are NTP. So the only network connections I have running right now are to synchronize my time. But if I were to start an SSH server, for example, you would be able to see that down here I am now listening on port 22. Now, this command, the tech L is for listen. So if you remove that, you can see what your only active connections are, and that sort of changes what we have, what we're looking at here. Because here we're looking at 68 and 67. Now, if you know your port numbers, you'd know that's DHCP, which is definitely something I'm using on this network. And then over here, port 443, that's web traffic that's expected. And down here, you can see sort of some process ID information, which is helpful. Again, the syntax here is ss-tulpn. Just to go through the flags one by one, the -T is for TCP connections, the -U is for UDP connections, the L is to include the port you're listening on, the P is to have the process ID present, and the N is for the name. Now the reason why we can't see process IDs is because it wasn't running with sudo, but if we run with sudo again, what we can see is all of the information is coming through. So if you're running into an issue where some of these columns are blank, you might just not have the right permissions to do that. Another important command here is ss-tunp. This will show you active connections, like I said earlier. The W command will show you people who are actively logged in, and you can see the only user here is me, which is expected. And so the final sort of concept I have for here is how to record traffic on a specific interface. There we use this utility TCP dump. Again, you're going to need super user permissions. Tech capital AV, that's just going to capture all of the traffic and keep it verbose. I is for interface. That will be our wireless interface because that's what we have connected. And then we're just going to output this to a demo.pcap file. And you can see here it's telling us how many packets it's collected so far on the network. Now if we kill that, we can see demo.pcap has been written. And if we go here and run Wireshark, we can open demo.pcap and see sort of all of the packets there. So that's how you can capture traffic on an interface and then look at it through a tool like Wireshark.